In the next few examples, we want to use Symbolab to solve applied problems that involve quadratic equations. For example, in 13, we have an equation for the total profit for a company after producing and selling X units of a certain product. We want to find the production levels that will create a profit of $543.88. That means we want to find when our equation will be equal to 543.88. We can switch over to Symbolab and ask it to solve that expression, negative 0.00353x squared plus 13.136x minus 6,969, should be minus, not equals, minus 6,969.889 equal to 543.88. It's going to give us two exact answers involving square roots, but then under that we'll see two decimal approximations. Since we're talking about units produced, we want to go ahead and round those to the nearest whole number, meaning the production levels that would yield this desired profit would be either 706 or 3,015 items. Units. In example 14, we're given an equation for total profit again, after producing and selling X units of a certain product, but in this case we want to find the break-even points for this company. Whenever we talk about profit, our profit can either be positive, negative, or equal to zero. When we look at the portion of this curve that's above the x-axis, that's where our profit is positive, so we're generating profit with the number of units that we're producing and selling. And then we have two regions that are below the x-axis. On the lower end, on the left end, our profit is negative because we're underproducing. We're not moving enough units to cover our costs. And on the higher end, those negative profit values represent where we're overproducing. So our costs are exceeding the amount of money that we're bringing in from producing and selling that item. With break-even analysis, what we're looking to do is find the 2 points where our profit has a value of exactly zero. Because we're breaking even, we're bringing in as much money as we're spending. In order to do that, we'll take our profit equation and solve it set equal to zero. So we'll delete what we've got in there, and now we'll solve negative 0.000004x squared. And actually, let me go back. I've got one too many zeros in there. Plus 0.175x minus 157.243. Again, we'll set that equal to zero because we want to determine the x values that give us a profit value equal to zero. We get two exact and two approximate answers again. Rounding those values to the nearest whole number, since we're talking about units produced, will tell us that our break-even points would be at a production level of either 1,263 or 3,112 units. Example 15 is a very similar question. The only difference here is that we're given the revenue and cost equations for this scenario rather than the profit equation. But if we think back to what we did in the previous example, we solved for where our profit was equal to zero. We also know that profit is equal to our revenue minus our costs, the amount of money that we bring in minus what we have to spend. So we could update that first equation to, instead of being profit is equal to zero, we could say that revenue minus cost is equal to 0. And if we add cost to the other side, we get revenue equal to cost. So we can find break-even points by setting a profit function equal to 0 and solving, or by setting a revenue and a cost equation equal to each other and solving that. But we have the same scenario that we're looking at. We have a portion of this graph where our revenue is exceeding our costs, and then we have portions of this graph where our costs are exceeding our revenue. So what we're looking to find are these 2 points where our revenue and our cost intersect, which again represent those break-even points. In Symbolab, we'll take a very similar approach. We'll solve our first equation, but then instead of setting this equal to 0, we input the revenue equation, so now we'll input the cost equation. And solve to get production levels of 842 units and 2,171 units. And again, what we found are the production levels that would give us those break-even points, where our revenue equals our cost, or where our profit is equal to 0.